This is problem 16 from the Gynecology Physics for Scientists and Engineers, 4th edition. In this problem, we're given a position function. X is in meters, T is in second. We are given the position function, and we would like to determine the position of the ball at certain times, the average velocity over the interval 1 to 3, and the instantaneous velocity at 2 seconds and 3 seconds. Position function so to determine the position of the ball at the times that are given 1 second, 2 second, 3 second, all we have to do, this is the position function. So in order to get the position in 1 second, we plug the times. Plug and chug. So 1.0 second, 2.0 second, and 3.0 second. Plug and chug. So the first one is going to equal negative 0.5 meters. Second one is going to equal 0.8 meters. Third, 1.1 meters. So now we have the position of the ball at the times that are given. Now to find the average velocity, in order to find the average velocity, we need a equation. So average velocity is going to equal dx over dt, the change in distance over the change in time. For the first position, we had a position of negative 0.5 meters. The third position I meant, we had 1.1 meters. So the change in distance would be the final distance, which is 1.1 meter, minus negative 0.5 meter. This goes to a positive sign. And the change in time, which is 3 seconds minus 2 seconds, minus 1 second, is equal to 2.0 seconds. So the average velocity is going to equal 0.80 meters per second. So now we need the instantaneous velocity. What that means is we need the velocity at specific times for it to be instantaneous. So all we have to do to get the average velocity, all we have to do to get the instantaneous velocity, we have the position function. In order to get the velocity function, we take the derivative and we get the velocity function. If we take the derivative a second time, we get the acceleration function. Well, we only need the velocity function, so we're going to work with this. To get the velocity function, we take the derivative in terms of t. And that is going to equal the velocity function. Once we take the derivative, the function is going to equal negative, because the constant goes out. So the 2.0 meter goes out, that's a constant. So now the negative 3.6 meters per second times time, so let me do the derivative over here. So 2.0 meter per second, that's a constant, that goes to 0. Negative 3.6 meters times t. 1 goes in front, and the t goes to 0, plus 1.1 meters per second square and t squared. So when you look, so 2 goes in the front, right? 1.1 meters, so this is meters per second square. And we minus t, we minus 1 from the 2. So this is equal to negative 3.6 meters per second plus 2.2 meters per second square times time. So now all we have to do to find the instantaneous velocity is plug t equal 2.0 second and t equal 3.0 second. When we do that, the instantaneous velocity at 2 seconds is equal to 0.8 meters per second. And at 3 seconds, it's equal to 3.0 meters per second. To solve this problem, all we need, we have the position function. Once we get the position of the ball, by plugging and chugging the times, we need the velocity function. What we do is take the derivative of the position function, which is equal the velocity function, and we just plug and chug the time and we get the instantaneous velocity. And as you know, for the average velocity function, it is the change in distance. So final distance minus initial distance over final time minus initial time. And that's all.